Physical Science. This is Mr. B. We're going to start Section 2 today. The title of Section 2 is The Structure of an Atom. So now we're going to take a look at, obviously, hopefully you know what structure means, how the atom is actually made up, how it's composed, what the actual parts are, because we just talked about several scientists that helped us kind of almost make it to this point, but none of them actually had the 100% correct idea. They're almost able to help us describe all the pieces of the atom, but they weren't exactly sure how they were actually assembled. So that's what we're going to take a look at over our next several sections. I think we have only 2 sections left actually, is how an atom is actually made up and what its pieces are. So to start, again, they always give us a little comparison or analogy, a real-life example to kind of help us introduce the section. So for this one, they talk about this 45-foot steel sculpture, and it's made up of 10 tons of steel. So over there on the right, it's basically just a giant paperclip. It's made up of 10 tons of steel. And they are kind of making a real-life example, saying that here, if a proton had the same mass as that sculpture, so if protons weighed 10 tons, then an electron would have a mass of only about 5 kilograms. So that's showing us that the size of an electron is much smaller than the size of a proton. So that is kind of, again, like an analogy, kind of a real-life scale sample there, that if we took a proton, magnified it up to 10 tons, if we wanted to keep it to scale, we'd only have to make an electron up to 5 kilograms to keep them the same, to keep the proportions the same. And so to start here, we're just going to go over the 3 subatomic particles, and remember, subatomic means smaller than an atom, and so we have 3 subatomic particles, and those are the protons, the electrons, and the neutrons, which hopefully we have heard of these before. So to start, we're just going to get the general properties of each one of these. So based on experiments with elements other than gold, Rutherford concluded that the amount of positive charge varies among elements. And so that means that gold is going to have a different amount of positive charge than hydrogen, than helium, than all of those different atoms, or other different elements. And a proton is our positively charged subatomic particle, so I'd make sure you wrote that down, and that it is found in the nucleus of an atom. So protons are positively charged, they're found in the nucleus of an atom, and each proton is assigned a charge of 1+, and each nucleus must contain at least 1 proton. So those are our main characteristics of a proton. Again, they're positively charged, they're found in the nucleus, and if you have, again, just 1 proton, you just get a 1+, and again, each nucleus must contain at least 1 proton. So protons, positive. So our next one are the particles that Thomson detected, and they were later named electrons. Remember, Thomson had the beam of light that was charged, are caused by a negatively charged particle because, remember, it was attracted to the positive plate. And an electron is a negatively charged subatomic particle, and it's found in the space outside the nucleus. And each electron has a charge of 1-. So instead of, again, Thomson, he was saying it was a plum pudding model, that all the protons are spread out and then the electrons were kind of embedded within the protons. What we know now is that the electrons are completely separate from the protons. Protons are condensed down into a nucleus, and the electrons are in a space much farther away. Again, they're not condensed down in that nucleus. Again, they are negative. So protons, positive, electrons are negative. And then our last subatomic particle was discovered in 1932 by an English physicist by the names of James Chadwick, and he carried out an experiment to show that neutrons do in fact exist. So he concluded that the particles he produced were neutral because a charged object did not deflect their paths, and we know now that a neutron is a neutral subatomic particle that is found in the nucleus of an atom, and it has a mass almost exactly equal to that of a proton. So we have protons, neutrons, and electrons. Protons are positive, neutrons are neutral, electrons are negative. Again, they don't go into too much detail about Chadwick's experiment, but he did figure out that there was another particle in there other than the proton, and we might talk about that a little bit more in class about how exactly he did figure that out. And so to wrap this up, we're going to take a look at some of the properties that we can use to compare these 3 subatomic particles, and the way we can tell them apart is there's 3 main ways. The first one is the mass. So basically how much weight they have, how much space they take up, their charge, which we just talked about, positive or negative or neutral, and their location in the atom. So are they in the nucleus or are they in the space outside of the nucleus? So that's how we're going to tell these particles apart. And everything scientists know about these particles is based on how the particles behave in experiments. Scientists still do not have an instrument that can show the exact inside of an atom. So this chart right here just kind of gives us some general overview of the properties. Again, I would never really necessarily have you memorize all of this, like you're never going to actually have to know the actual mass, but I would say some things to take away would be the charges and the relative mass. Again, a proton and a neutron are about the same size, and you can see here that an electron is much smaller. So being able to read this chart is probably more important than actually having to memorize it. So maybe don't worry about jotting any of this stuff down. Maybe just, I would say, the most important part is knowing the charges and their masses, which we will get to in our last slide here for this video. And it just kind of gives a little bit of a summary of the similarities and differences that were just mentioned in that chart right there. So to start, so this is probably the things I would write down. All three of these things are fairly important here. So protons and neutrons have almost the same mass, which we just saw. They both had a 1, and about 2,000 electrons equal the mass of 1 proton. So if we go to this chart right here and look that an electron is 1 over 1,836, meaning that you would need 1,836 electrons to kind of equal the mass of that 1 proton. So they just kind of rounded it up to 2,000 there. So electrons much smaller than protons and neutrons. An electron has a charge that is equal in size to, but the opposite of, the charge of a proton. So even though their size differences are so different, even though the proton is so much bigger than the electron, their charges are still the same. So an electron's negative charge cancels out or balances out directly perfectly with the proton's positive charge. And the neutrons have no charge at all. And then the last one, protons and neutrons are found in the nucleus, while electrons are found in the space outside the nucleus. So we are going to do some more work with protons, neutrons, and electrons in class tomorrow. Just so make sure that if you have any questions, you write them down and let me know.